Hello, this is mlcourse.ai, lecture 1, Pandas data analysis. So first you can have a look at introduction in the same YouTube channel, and now we go actually into course content, and first we'll discuss data analysis and visualization. So these are topics for our two lectures, and then we'll go actually into machine learning, covering decision trees. So this will be really fascinating for beginners who first think about, first hear about machine learning. And actually for all real-world machine learning tasks, data analysis is crucial. So first you have to get data, to prepare it, and do some manipulations with that. So we'll skip the task of stating a business goal and defining your project, your tasks. We'll also skip preparing data sets and getting accesses to databases, matching data, and so on. We'll assume we already have data, and what do we do first, what insights we get from data, and how we actually prepare it to work with machine learning models. So typically I'm starting lectures with some theory, then I code live right here. But so with Pandas, my theory will be just 5 minutes long. I'm just going to present what I'm going to do, and then we'll just switch to coding. So really not much theory here. So we're going to work with Pandas. And in introduction we covered how to set your environment, Jupyter notebooks, and so on. So if you installed Anaconda, you already have Pandas Library in there. So in Pandas we'll work mostly with data frames. So sorry for my writing. I'll get used to it. Data frames are really nice data structures to represent real world, so some real data sets. So we'll mostly work with tabular data. So we'll have some sort of tables like this, and we'll have instances, our rows. So these are going to be rows in our dataset, and they will stand for some instances in our machine learning problems. So pretty often these are people. So let's say we'll have clients, some features of our clients. So rows will represent clients. But it's not obligatory. Instances can be anything. Images, some web session tracks, and so on. So these can be anything. Columns are typically called features. So we'll have features for each of our instance, for each row. And let's say for clients we'll have age, salary, and whatnot. Maybe number of children. Okay, so we are not here discussing getting data and where do we get age from and how we infer age from our clients, whether we have missing data or not. So for now, let's just focus that we have data, and this is how it's structured. So these are all are going to be columns. Okay, so it's obvious these are columns, but columns are going to represent features. These are sometimes called attributes as well, or just variables, but we'll stick to the definition features. And pretty often we'll have some feature which doesn't resemble any other. So we'll call it a target feature. And let's say for this small data set, this will be churn. So either a client is with us, is loyal and using our service, or the client has churned, so stopped using the service. So let's say it will be labeled as 0101. So we'll cover such example pretty soon. Okay, again, really complicated business task, how to predict churn, how to get data like this, and actually what we call by churn, how we define it. But let's say it's already solved and we've got a data set with a target feature like this, churn. So typically it's located to the right. So this is typically a feature we are going to predict. And if we have data like this, we've got target or labels, we'll call it labeled data. And in the machine learning task, this will be our training set. I'm not giving mathematical definitions yet, but just suppose we've got a table of rows and features, and we've got one target feature, so this is our labeled dataset. It turns out that Pandas DataFrame is almost perfect to work with such data. So in pure Python, we have lists. Let's start with a list. Ages, so values of an age feature, let's say 17, 82, 7, 40. I just drawn a Python list. In NumPy, you'll have some wrapper, NumPy array. So typically it's called designated NP. NP array will be some wrapper around lists. So I'm not very strict here, so there are many differences between NumPy arrays and lists. So I'm just expressing a simplest way to think about it. So in NumPy, you can do simple operations with such arrays, additions, multiplications, transposing, multiplying a vector by matrix. You have lots of linear algebra algorithms implemented here in NumPy. So just to realize it, putting simply, it's really efficient analog for Python list, so that you can do manipulations pretty easily with NumPy arrays. And in our data science applications, we'll call it such functions like summing all values in a vector, calculating median or mean. So these simple things are implemented in NumPy. But for real world applications, so for actual data, we would like it also to be indexed and having a label. So actually we'll convert it into a feature. And a feature has nice attributes such as an index and a name. So actually Pandas series will be a perfect data structure to represent a feature. So Pandas series will actually be the same NumPy array, but also with the index and with a name. And of course, there's much more to that. Pandas series has lots and lots of functions, attributes, and so on. Really very, very rich class. But for now, let's just realize that we'll have a NumPy array like this. NumPy array. It will have an index, and it can be anything, not only integers, but let's say strings. We can put names here, Kate, Leo, Max, and so on. And we'll have a name. So a name for this feature will be age. So this all will construct a Pandas series object. And now a data frame is a columnar data structure. So in a nutshell, a data frame will be a dozen of such Pandas objects staying all together side by side. So these are Pandas series objects. This 1, 2, 3 will be age, salary, and let's say debt. So these are all PD series objects. And a simple way to visualize a data frame is just these couple of Pandas series objects united all together in a new data structure, DataFrame. Again, much more to that, loads of methods and attributes in a DataFrame, but still, essentially, it's a columnar data structure, so an efficient index here is on columns, so you can easily get a Pandas series object out of DataFrame. So actually, that's all about explaining. We'll currently get to actual data, and I'll show this more, but only in code. Okay, and I opened Jupyter notebook. So if you don't know what this stands for, go to lecture 0, introduction. But here I have a notebook running, and now I'm going to actually write some code and show you these opportunities of Pandas library. So I import pandas as PD, so it's sorry, and already I missed a typo. Okay, I'll get used to this keyboard and so on. Okay, I'm importing pandas as PD. Very popular alias for pandas is PD, and I'll get some actual data reading from file read CSV. We can see Pandas has lots and lots of opportunities to read data from pickle file, from Parquet or Feather, or some more formats, HTML, JSON. With some I'm not familiar. You can read from SQL and so on. But here we'll suppose we already get data in a CSV file, and we need to specify just a file path. Remember Shift Tab, so read CSV, Shift Tab, and we've got this inline documentation, and the first argument to pass is just file path. You can make it a named argument, but not necessary. Maybe you can pass just a string. And I'll go one catalog up, then I've got data here, and I'll read beauty dataset, beauty.csv. This will actually return a data frame. I'll call this local variable df. So df will be pandas core frame data frame. I'll make it a bit larger. Yep, okay. So now I have data frame. The first thing to do is to take a look into it, several columns. This is essential to do, very important, because thus you can make sure that you read data correctly. So I'm intentionally showing this example that here we didn't read this data correctly. I need, so obviously comma is not a separator here. I need to pass another one. It's argument sep and this semicolon, and now we have our data. So you can see features here. So we've got some data. I'm not going deep into the source of this data. I just know that this is some social questionnaire, and some society published a paper in statistics journal, and here are just some social demographic data. Let's just quickly skip through it. Wage. So wage is how much guys earn in dollars per hour. Then experience in years. Union is whether they are members of some professional union or not. Whether they estimate their health as good or not. Okay, some social demographic features. I don't remember each feature. Some services. Okay, don't remember. And finally, looks. It's some attractiveness. I think it was graded by readers of the journal, giving some marks for photos of some models or so on. Okay, just some attractiveness. We'll get some insights into this data. We are not going to predict here anything, but still it's interesting to understand this data and to find some particular insights into that. we'll actually do it. At the same time, I'll show you basic things in Pandas. Okay, so in this data frame, index is done over columns. So if we just take wage as an index, pass it as an index, we get Pandas series. So the type of this object is going to be Pandas core series. So you see, just with square brackets, we have an index, and it shows that by passing a string with a column name, I can easily, quickly get a Pandas series object. I can do head here as well to show only 5 rows. And you see we have index here. Now it's just natural, 0, 1, 2, 3, 4. And we have values. We also have name. This is wage. And data type, this is float 64 data type. Now we've got only a bunch of features here. Let's take shape, and it's 1260 by 10, so number of rows and columns. If we have 10 features, we can easily see all of them, but if we have 3000 features, it won't be that convenient. We can take columns attribute to get all features, and we see it's index with actually all feature names. Some general information about DataFrame is the info method. It will show you that we have 10 features here, number of observations for each feature. It's really nice that we don't have missing values here, non-null, so 12, 60 non-null values everywhere. That means that there are no missing values. So missing values is also some tricky thing to do. Yep, so you'll need to handle these missing values. And it shows you types of each feature. So we've got 9 integer features and only 1 float. The info method also shows you memory usage. Here it's only about 100 kilobytes, but you'll definitely have larger data sets, and you'll be able to keep track of the memory used by actually this DataFrame object. To get insight into distribution of all features, the simple way to do thing to do is actually to call describe, and it will show you simple statistics for each feature. So maybe this is not really convenient, so on just a big table of numbers where you need to eyeball, but even with that you can already know something. Let's say the wage feature, we see that median is $5.3 per hour, 75 quartile is almost 7.7. That means that nearly 1/4 of our data is larger than 7.7. And we can see that maximum is 77.7. That is order of magnitude higher than 75% quartile. So we can conclude that this feature is distributed skewly just from these raw numbers. Okay, so actually visualization is a topic for our next lecture, but preliminary data analysis always goes with making some simple plots. So without going into technical details, I'll show you some simplest plots. And I'm importing matplotlib, so matplotlib library. So from matplotlib, I will import pyplot, and a common alias here is plt. This will let us plot simple things. And Pandas, I already told that Pandas implements some functions from NumPy, but it also has some visualization functions that are based upon matplotlib. So matplotlib is very low level library for plotting, so we'll cover it a bit next time, but only a bit. But with Pandas you can make some simple plots just by calling such functions like hist, and you get a histogram of wages. Okay, so here's how wages are distributed in this dataset. We can see that most values are lower than $10 per hour, but we have some outliers here, like 77. We can even do it for the whole dataset, though it's not always informative, and you can should better be careful with that. Sorry, not like this, but just df hist, and you can build histograms for all your features. Okay, we can customize, make it more beautiful. I'm not doing this right now, but still it's an easy way to visualize all distributions at the same time. You need to know that it can require some time. If you have some 100,000 instances and 200 features, this will be time consuming. What it does, it actually plots all distributions, and it's a nice way to visualize, to make nice summaries of all features just at the same time. I'll make the picture a bit larger. Okay, didn't work well with Pandas. Figure. Okay, we'll cover actually all these tricks of visualization next time. I'm not going to lose time on that right now. But still, from these plots, you can see how wage is distributed, how binary features are distributed. For this dataset, it's not very actually helpful, but we can easily take any feature and explore its distribution. So actually we've got one numeric feature, wage, here, and all others are int valued. So we can take, let's say, feature female and calculate its unique values. Unique will show you only 0 and 1, so male and female. It's convenient also to first check the number of unique values, non-unique and unique. And a nice attribute is a nice method is value counts, which will calculate you that there are 824 men here and 436 female in this dataset. A small detour, feature types in machine learning, so we'll definitely cover them when we speak about feature engineering and feature creation and just working with features. So it's important to distinguish several types of features in machine learning. We'll discuss it right now because Pandas can handle these different types, and it's really important. So you first have numeric features or synonym continuous. So these are something like age, salary, and so on. So of course you always have a limited dataset, but you should think of this feature as being able to have almost any value. So that's why it will be expressed as a float of type float. It may be double, float 64 and 32. I will just say float, meaning that it's a numeric feature. It can take any possible value. We'll also have categorical variables. These are typically expressed with strings, and the most important part is that values of categorical features don't have any order. So examples are city of origin of a client, or some service type, if you have, let's say, 5 service types, or something like that. So the most important part that for city you'll have values like Los Angeles, New York, Moscow, Amsterdam, Paris, and you can't compare these values in any way. While for a numeric feature there is a natural order, 17 is less than 28 and so on. Ordinal features are very similar to categorical, only that you have a finite number of unique values, but you also have order there. So there's only a slight difference here, but let's say education. Sorry. So for education, you might have values like primary school, high school, then maybe PhD, and so on. And definitely there is an order here, but still this feature has a limited number of unique values, and this can be also represented by string. If it's represented with int values, it still can be the same. What if you just have a dictionary which maps 1 to primary, 2 to high school, 3 to PhD? You can have an int valued feature, but essentially this will, by its nature, it will actually be an ordinal feature or even categorical. Okay, and finally we'll have binary features, which are actually it's a special type of categoric, but it's convenient to say that it's one more feature type. Binary feature. Okay, yep, I see that I'm writing over my video recording. Okay, no, not very convenient. Okay, a binary feature is just 0, 1 valued, or again something else can stand for 0 and 1. So male and female can be written in strings. Male, female. So it's again it's it can be represented with strings or ints. Okay, so to be pedantic, it can even be represented with floats 7.5 and 6.2. If you only have 2 unique values, this can also be a binary feature, but typically we'll represent these with strings or ints. And so Pandas can conveniently handle this. So by running df-info, we've seen that we've got one numeric feature here, wages, and all others here are int valued. Some of these are binary. Looks, let's take a look at feature looks. This is an ordinal feature. So looks has 5 unique values, and unique will return 5. So unique values are 1, 2, 3, 4, 5. Value counts. Okay, so 5 are attractive guys, 1 are just ugly, most of people are somewhere in the middle. Well, I don't know the source of this data, just maybe some subjective estimation of people's attractiveness. But we see here we definitely can make an order, and the number of values is limited, so this is an ordinal feature. So if you wonder what's the percentage of healthy people here, I think again this good health feature is something really subjective. So whether a guy thinks he or she is healthy or not. But if you're just interested in percentage, you can calculate mean. So 93% are healthy. You can calculate again the distribution, value counts. You can normalize it, passing normalize equals true, and you have 93.3 healthy people, 6 and almost 7% of folks consider themselves unhealthy. Okay, of course, a very important thing to do is to get data from your Dateframe. So, indexing. Indexing your data is done in two ways with data frames. We said that you can have an index here. So if you need indexing just like in NumPy, just geometrical indexing, you would go for ilog. Ilog method, it's indexing the same as with NumPy arrays. Okay, if you need to get a value in first row, so index 0, and let's say 6th column, so it will be 5, you just get this value, it's 1. If we return here, it means it's row number 0, 1, 2, 3, 4, 5, 6, female, so this is value 1 in this place. It's convenient for writing loops if you actually need to work with your data frame and by making some operations on particular values in your data frame. You can pass slices here. So these are first 6 rows and the 5th column. And again, we can pass slices here from 5 to 7. And we get a subset of our data frame. We can actually save it into a new data frame. So because actually what's depicted here is also a data frame. I'll create a small data frame. I'll call it toy.df. So just by calling pd data frame. So I'll pass a dictionary to constructor. So the constructor here is again very, very rich, lots of opportunities to initialize a data frame. I'll just show you that you can index your data with something more interesting than a natural integer index. So let's say we'll have 3 guys, and they will have an age feature, and I pass a list 17 years old, 32, and 56. And I'll have let's say a salary feature. Maybe it's in thousands per year. 56, 69, 120. And as an index, I can pass almost anything. Here I'll pass Kate, Leo, and Max. And it's a data frame. So you see, I can print it. It's very small, toy.df. So we've got a data frame, and now we can index its data. So with ilog, you just get, again, index your data in the same way as with NumPy matrices. If I pass 1, 1, I get Leo's salary 69. Okay, but method log can use pandas indices. It can be much more convenient. With the log method, I can pass names here. So my indexes here are actually strings, and I can subset data. I can take, let's say, only Leo and Max and select only age feature. And I've got pandas series, Leo, Max, and their age values. Okay, so actually we'll start asking questions to our data. So subsetting data based on some condition is one more important thing, Boolean indexing of your data frame. So actually you can take some pandas series and compare it to some value. Let's say we'd like to know who are the richest people in this dataset. So we can take our wage feature and compare it to some value or a threshold. Okay, if I compare it just to 40, I get a binary pandas series. So it's actually a wrapper around binary NumPy array. Okay, and it's clear whether the value is 40, then there will be true. And I can calculate the number of such observations. If I sum it, okay, no values 40 exactly here. But it's a numeric feature. It's more interesting to compare it to some threshold. Let's select all people who earn more than 40 dollars per hour. Again, a binary feature, but now the most important part, I can subset my data just with this condition. And now I get all folks that earn more than 40 per hour. Only two guys like that. So here we see 77.7, now 41.7. So these are outliers actually. So it's not typical for this data set. And we can study these guys more if we'd like to. Just the way of indexing our data. Now we can do more than that. We can combine several conditions like that. So if I'd like to add one more condition, I need to stick to brackets. And if I use AND operator, here it's ampersand. So if I'd like to subset with some more condition, let's select only women who earn more than $20 per hour. This is how I get this subset. Okay, it turns out only this outlier is a female earning so much. Let's lower this threshold. Okay, and we have more folks, more females earning more than $10 per hour. So this is Boolean indexing. Sometimes I've heard it's called masking, but it's really convenient to actually subsetting your data and asking questions to your data. Some more things to show. So very convenient way to work with these features with Pandas series is apply. Apply is a bit of functional programming. So I can take some feature, let's say female. Let's recall that these are only values 0 and 1. And I can create a new feature by working with an old feature. Let's say I would like to create a feature with values male, female, based on this binary feature. But what if I just want to have a feature valued male, female, so it will be string valued. I can do it by applying a new function to my Pandas series. So here I'll pass a function, and a function is going to be really simple. So what I'm doing here, it's an overhead. For such simple thing we can create, we can do it in different ways, but I can pass a function called let's say gender ID to str. So an ID will be converted to a string, and I get gender as an argument. I'll get gender ID, and I'll write a one-liner, return female if gender ID equals 1, otherwise return male. Okay, it's not a really nice function because it will return female if gender is 1, but otherwise if you pass any value except for 1, it will return male. So I can pass else if here, so elif operator, but it doesn't matter. I'm just showing that you can have a function, and you can pass this function to apply method to get a new Pandas series, a new feature. That's actually overhead for such a simple function, and very convenient thing to do is to use lambda functions together with apply. So we can do the same, but instead of defining a new function here, which is really ugly, we can define it locally, just in line with a lambda expression. I'm typing a word lambda, and the syntax is really simple. You write an argument, so the only argument this lambda function takes, gender ID. You put semicolon and then just in line an expression that is returned by this function. So I'm directly writing the same expression, and we are doing the same. Female if gender ID equals 1, else male. And I've got the same result. Actually, the same can be done with a map method. Again, a bit more functional programming. I would say the quickest way to do this is just to have our initial female pandas series, and I map all values by passing a dictionary. So I'll map 0 to male and 1 to female. And again, the same result. We'll have more examples of apply and lambda functions when we cover lesson 1 material. So now I'm showing it in detail, but then I'll just skip through lecture 1 material and show all this, how it actually works and where apply and lambda can also be used. One more thing to do is to group our data. So those familiar with SQL should know group by, and it's also very convenient and it's implemented in Pandas. So let's say, what if I'd like to know some statistics of wage distribution, but for males and females separately? Okay, I can do it just by hand. I would say ugly. So I can subset with lock method. I can subset only males. Let's say female equals 0, so I subset males. And I can take a look at wages and calculate, let's say, median. And I get $6.4 per hour. I can do the same, but for females. If I change this condition to 1, I've got a median 3.75. Well, yeah, not going to comment this somehow, just features of this dataset. So male here get more. Okay, but speaking about nicer way to calculating such statistics, I can group my data by some condition. So I write pd group by, and I'm going to group data by feature male, female. If I execute it, it's not really interesting. Sorry, not PD, but df. But still not very interesting. So it says it's only some object, DataFrame group by. So it's actually a generator. So here is the place where knowledge of Python can help. So in Python, you can create, let's say, a list of some values, but you can also create a generator. So suppose you'd like to generate all numbers from 1 to a billion. So a very bad idea would be just to create a list with all values from 1 to billion. So it's going to require much memory. Really simple to generate a next element of this sequence is very simple, just increment by 1. And you can store your previous value, you can store the rule how to generate new value, just increment by 1, and thus you get next value just by iteratively applying this incrementation rule. So using generators is much more memory efficient in some ways, and here Pandas group by is also a generator. So it's supposed to be processed in a cycle. So we'll have some elements in a cycle, and let's just discuss what are the elements of this generator. So actually this will be I'll call this again gender ID and sub df, sub DataFrame. So actually these variables in this cycle are local. We can give any name for that. I can call it sub DataFrame. Let's just print gender ID to see that it's very simple. We first have zeros, so male, and then 1 females. And sub df will be a sub DataFrame. Let's for now print its shape. So 8, 24 males and 4, 36 females. But this is actually a DataFrame, only that it first has all males and then all females. And we can do something like that. We can format our string a bit more nicely. We can say median wages for men are for men and women. I have a placeholder here and a placeholder here, and I'm going to format my string by passing, what shall I pass? So I want to pass here men if gender ID equals 0. Else I will just pass female, but women. Yep, I'm passing women here, but not a nice practice. What if gender ID has something else? But for this example, it's going to work. And here I want to pass a median, so I get sub DataFrame. Calculate, so take wages and calculate median. Okay, and I'm commenting this. Something wrong, of course, not wages, but wage. Okay, and I have the same, but more nicely printed. So this gives you lots of opportunities. You can do different things with group by, and for such simple things, Pandas has a nicer syntax. So you can group by this feature, and then you can pass numeric feature that you are interested in. So here it's wage, and then you can apply these simple functions like median. So this is how we get the same information, but just more in a more funky approach. And here I'll go to actually lesson 1, Pandas data analysis. I'll show you the general syntax of this construction with group by. So we'll discuss this topic just in 5 minutes. Here I'm going to show this syntax for group by. One moment. Okay, Control F. Grouping. So you have your data frame, you have a group by, you pass columns that you want to group your data on, then you pass some columns that you are interested in to calculate some statistics, and then you pass functions. So it works like this. So for group by we can pass more features than just one. We can group our data both on gender, let's say we take also merit, so we'll group our data into 4 subsets, male, female, merit, non-merit, and we calculate the same. Okay, how do we read this? So we first have men, non-married men. Wow, already nice observation that married men are a bit more, so earn a bit more, so it's really very nice to get married, so you are going to earn more. Okay, yep, so this jokes are jokes, but still I would say that these are only observations. You need to carefully verify them. So I'm not going here deep into statistical hypothesis testing, but all such observations should be actually verified. In real tasks, you go to analysts and they're going to set up some experiments to check your observations, to verify them. But for initial data analysis, sometimes it's just convenient to find any insight and to generate a corresponding feature, or just to find something really interesting in your dataset. Here, an interesting observation would be that married men are richer than non-married. This doesn't hold for females. Okay, but this is only for this dataset, only a bit more than 1,000 observations, so not really, no serious conclusions from that. Okay, so this group by is really handy. I'll show just a bit more about studying interaction of binary and categorical variables. So you also have a nice thing, CrossStep. CrossStep will show you the distribution over two categorical variables or binary. So for the same for females and married feature, I can quickly know that there are 166 non-married males and let's say 213 married females. And it's actually convenient, so those familiar with Excel will see some analogies with cross tables there and with pivot tables. So actually for some questions concerning distribution over two binary variables or categorical, this can be really handy. Okay, some more interesting insights here. I will use visualization for that. I'm using Seaborn library. It's one more library that's based on matplotlib, and it needs to be installed additionally, but it's very quick. Pip install Seaborn, or for Anaconda it will be conda install Seaborn. And it can plot really very nice figures, really nice plots, just with a bit of code. A typical alias for that is SNS, and let's say I'd like to study the relationship between wages and education. So we have a feature education here. We haven't studied it yet, but let's take a look. So here we'll build some plots for interaction between wage and education. So first, what's the type of feature? This educ, standing for education, number of years that a person studied. We can have a look at number of unique values, so only 8. We can calculate value counts. So we see the distribution of this variable. So actually it's numeric. But here only 8 unique values. We can treat it as an ordinal variable, and we can plot actually the distribution of wages for each unique value of education. Let's plot a boxplot. So I'll first show what it is. SNS boxplot. I'll plot this thing for variable wage, and I'll pass data. So data is our data frame. And we see such picture. That's a small summary of our distribution. Only that we've got outliers, and I'll restrict our data to exclude these outliers, I'll subset wages that are less than, let's say, 30. Okay, so here are wages, wage distribution. So it's not actually a distribution, but it's a quick summary. So here it's called a boxplot. So we have a box here. In the middle, we've got a median. So around $5 per hour is a median for this feature. This left and right border are quartiles, 25% quartile and 75% quartile. So in a nutshell, so this right border is about $7 per hour, and nearly one quarter of data, one quarter of values are higher than $7 per hour. And by the same token, here we've got around 4, it's a 25% quartile, and about a quarter of data lies below this value of 4. Here we can see dots. These are, I would say, these are outliers. And these, how do you call this? These ticks, ticks here are, so as far as I remember, from median we go to 1.5 times the width of this box. So actually the width of this box is called IQR. It's a nice statistic. Quartile range. So actually it equals this 75% quartile. Okay, I will call it just percentile 75 minus percentile 25. And it's analogous to, range, yep, interquartile range. And it's an analog for standard deviation, but it's not so susceptible to outliers. Like mean value is susceptible to outliers. So what if you have a feature salary in your dataset, but you've got Bill Gates, and if you calculate mean, that it will be really very much affected only by one observation, by Bill Gates' salary. But still, yeah, it's a sort of a problem. So from one point it's a real observation, but from another point it really damages all your distribution. And so interquartile range is something analogous to standard deviation, but outliers don't affect it so much. So a boxplot is really nice for giving a really quick summary of the distribution of a numeric feature. And we can plot such boxplots, but with interaction with some categorical variable. So here I'll pass education, and now with y-axis I'll pass wages. And now I've got the picture which plots the same box plots but for different values of education. And so here we can see some sort of a trend. So okay, maybe it's obvious, but the more people study, the more they eventually get. And I'm not going into statistical checking of this hypothesis. So if we really need to make a conclusion that this is the case, we'll preferably have a larger dataset and run some hypothesis checking on that. But for practical data analysis, it often suffices. So we just see some observation and make conclusions. And they would also joke that in business there is no time for significance testing. Just go and use the knowledge that you see. Okay, I shall be really careful with such exclamations, but still we don't really often do statistical testing when you just do preliminary data analysis. Okay, maybe it's obvious. So wages depend on education. Okay, nice argument actually for having some high school degree or university degree. But I would say that for different datasets, for different tasks, these can be not so trivial. So if you explore some features of particles in elementary, in physics, and in high energy physics, and if you're going to predict something, you really need to have domain knowledge, to consult experts, and studying this feature interaction is not so trivial anymore than in this example. Okay, now let's quickly go through this topic 1 notebook. It's the same as if you go to mlcourse.ai, and on the main page you've got all this material. If you click this one, this is NB Viewer. So for visualizing Jupyter notebooks, I would say NB Viewer is the best option. Of course, the same is well done in locally with Jupyter. I will only make a precaution that GitHub can render Jupyter notebooks not ideally, so you'd better go for Jupyter notebooks. So, for instance, if you go into this repository, mlcourse.ai, you find a notebook that you're interested in. Let's say the very same. So this is how GitHub renders it. It's doing its best, but it's not ideal. You'll see some figures might be missing, some layout is not the same. So it's really handy to have NB Viewer extension. If you use Google Chrome, you just click NB Viewer extension and you've got NB Viewer. But the same is already in the main site. I will just show you the same locally. Okay, nice Panda, isn't it? So we have basics of Pandas Dateframe, actually methods. So we covered simple methods and attributes of Dateframes. Here we'll read one more dataset, telecom churn. So now we have just a bit larger dataset, 3,3333 observations, so 20 features. These are all features. Information, again, we don't have missing values. Now we have a categorical variable, so it's purely categorical, state. Let's quickly cover some features. So here we have a feature we'd like to predict churn. It's a binary feature. We have state, so it's data from US. Total day minutes. This is how much clients actually use services. So these are telecom data. So these are something like average number of minutes on phone. And lots of similar features like that. When we cover random forest, we'll see how we can estimate feature importance, just to get the idea which features are most valuable. And now I will just say that total day minutes is a really important feature, and customer service calls. So if people have problems, they would call for support. And international plan is also going to be a nice feature. So if you're not comfortable yet with Pandas, just study this material thoroughly in detail, and I think it's going to be much easier to work with Pandas. Okay, so what I missed coding live is sorting. So of course you can sort your data by some feature in ascending or descending order. You can sort with 2 features as well. So it's now about indexing data, the same what I showed. Let's just get some intuition, some really nice insights into this churn data. Okay, some more examples of group by. So we group our data into loyal customers and churned ones. And here we can show statistics of such features as total day minutes. So actually how much people use services. And already an interesting observation here is that those who churn use phone much more. Okay, maybe not much more, but still more. And it raises a question. So why do people churn if they use their phone more than loyal customers? So it raises a question. Maybe they are not satisfied with prices, or maybe something else. But actually, this is something for an analyst to check. We can just make a conclusion that churned guys call more by phone. So why do they churn? Needs some investigation. Summary tables. So these again CrossSteps. You can create features just like just with passing a new value into DataFrame index. So we've got charges, day charges, evening, night, and international charges. I can create a new feature, total charge, just by passing this arithmetic expression. And so now I have a new feature. Okay, and this will be some nice plots. Count plot is actually the same as CrossStep, but it will visualize. We see that we've got a feature international plan, and when clients don't have international plan, the distribution is very skewed, much more loyal people. But if they have international plan as a service, the share of churned people is much higher, and it raises the question why this is the case. So if folks have international plan, we see a higher churn rate. Again, we only observe it, we can't conclude anything, so correlation doesn't imply causation. The same is here, so it needs to be studied. We can only conclude with this picture that international plan is going to be a really nice feature to predict churn. And further we can compare our models with this feature, and without that we'll see really nice, really high improvement if we add international feature. The same graph for churn and customer service calls. For different values of customer service calls, we see the distribution, and again, it's very skewed if there are not many service calls, 1, 2, 3, much more loyal people. And then starting with 4 customer calls, we see that there are almost the same numbers of loyal and churned customers. Okay, the intuition is really simple. If a customer calls service very often, maybe he or she has some technical problems, maybe even he or she is pissed off with something, and of course going to churn. And so, but here it's a nice observation that it starts from 4 customer service calls, and we can create a new feature, many service calls, just by comparing an old one with 3. And this is also going to be a nice feature, increasing actually the performance of the model predicting churn. So actually with this simple data wrangling, with building plots and actually calling pandas functions, we can find some nice intuitions and come up with some rules actually to predict churn. So let's say such a simple rule that if a customer has international plan as a service and has more than 3 phones to customer service, then let's just predict that this guy is going to churn, otherwise not. With this rule, we'll have about almost 86% accuracy on this data set. So of course we'll talk about classification metrics. The simplest is accuracy, it's intuitive, but we'll cover it much more in detail. You can think that this one is okay, that 86 is nice quality, but still reasonable baseline here is the fraction of loyal customers, and we can see that 85% of our customers are loyal. Let's just return here. Yep, 85.5 customers are loyal, and the churn rate is about 14.4%. 5%. So actually, if you always predict that customer is going to be loyal, you'll get about 85.5 accuracy. So this is not a really nice improvement over the baseline. And pretty soon, in lecture 3, we'll go into decision trees, and they will generate such rules automatically. So it will be really cool to see what rules decision tree generate. And we'll have accuracy about about 94 or 95, so much higher. And it's really fascinating how this can work out of the box. We'll just give data to a decision tree, it will build a bunch of rules, and we'll have both an accurate model and some really interesting insights to delve into and to analyze. And so actually you shouldn't underestimate preliminary data analysis. You can generate some really nice rules with that. It's a very important source of your insights into data. And the most important part is that you'll build your features. So you'll do feature engineering based on preliminary data analysis and building some plots. So that's it for lecture 1. So stay tuned. See you next week. We'll do more visualizations next time. Bye bye.